Welcome back. In today's video, we are diving into equations of straight lines from coordinate geometry, a must-know for O-level and IGCSE additional mathematics students. Before we begin equations of straight line, let's do a recap of finding the equation of the line which you people have already done in mathematics. The line L passes to the point 5, -1 and is parallel to the line y is equal to 2x minus 3. Write down the gradient of the line L and find the equation of the line L. It is given the line L passes through 5, -1 and is parallel to the line y is equal to 2x minus 3. If the lines are parallel, then their gradients are same. So we have here y is equal to 2x minus 3. If we compare it with y is equal to mx plus c, then this 2 is the value of m, which is gradient. So gradient of line L is 2. Now we have to find the equation of line L. We have gradient, which is m is equal to 2. We have coordinates 5, -1. The line L passes through the point 5, -1. So this is the point which is on the line L. To find out the equation of line, we have to substitute these values in y is equal to mx plus c so that we can find out c, which is y-intercept. This is x and this is y. So -1 is equal to 2 into 5 plus c. So -1 is equal to 10 plus c and c is equal to -11. Equation of line L is y is equal to, in place of m, we will substitute its value, which is 2x minus 11. So y is equal to 2x minus 11 is the equation of the line L, which is passing through the point 5, -1 and parallel to the line y is equal to 2x minus 3. There are three major forms of the equation of a straight line you should know. One of it is slope-intercept form, which is y is equal to mx plus c. For example, if we have to find the equation of the line with slope 2 and y-intercept -4, we can easily form the equation. We just need to substitute the value of m and c in the equation y is equal to mx plus c. This slope is m, so m here is 2, y-intercept is c, so c is equal to -4. When we will substitute these values in the equation, we will get y is equal to 2x minus 4. Another form of the equation is point slope form, in which we will use y minus y1 is equal to mx minus x1. It means that we must have gradient and coordinate of one point. Let's do an example. Find the equation of the line with slope 3, which passes through 1, 2. Here, m is 3 and coordinates of a point are 1, 2. We can simply substitute in this form of the equation to find out the equation of the line. Y minus 2 is equal to 3x minus 1. We have now y minus 2 is equal to 3x minus 3. Y is equal to 3x minus 1. Another form of the equation is y minus y1 upon x minus x1 is equal to y2 minus y1 upon x2 minus x1. This form is to be used when When we have two coordinates, one of the coordinates is x1, comma y1, and another coordinate x2, comma y2. Whenever there are 2 points, we can use this form to find the equation. Find the equation of the line which passes through 1, 3 and 4, 7. There are 2 points given. We can say this is x1, this is y1, this is x2, and this is y2. We can substitute it in this. Y minus y1 is y minus 3, x minus x1 is x minus 1, is equal to y2 minus y1, 7 minus 3 upon 4 minus 1. You see, this is the formula for gradient, y2 minus y1 upon x2 minus x1. Instead of taking out gradient separately, we are just writing it in this formula. So y minus 3 upon x minus 1 is equal to 4 upon 3. We can do cross multiplication. 3y minus 9 is equal to 4x minus 4. Finally, we have 3y is equal to 4x minus 4 plus 9 would be plus 5. We can leave the equation in this form, or we can write it as 3y minus 4x minus 5 is equal to 0. Or we can write it as 4x minus 3y plus 5 is equal to 0. We can change the sign of all this. Or we can write it in the form y is equal to 4x plus 5 divided by 3. So we can write it as y is equal to 4 upon 3x plus 5 upon 3. All these forms will be acceptable. Now we are going to do equation of perpendicular bisector. Perpendicular bisector is the line which intersects another line by making an angle of 90 degrees and at midpoint. So if this is the line, this line is the perpendicular bisector of this line. It is making an angle of 90 degrees and it is dividing this line into two equal halves. Let's do an example. Find the equation of the perpendicular bisector of the line segment joining the points A 1, 3 and B 7, 11. If suppose this is the point A whose coordinates are 1, 3 and this is the point which is 7, 11. We have to find the equation of the perpendicular bisector of this line. This is the perpendicular bisector. If we have to find out the equation of this line, we must have one of the coordinate and the gradient. Now, this line is perpendicular to this line. So if we take out the gradient of AB and take negative reciprocal of it, that would be the gradient of this perpendicular line. Another thing which is required is coordinates of one of the point of that line. For the coordinates of line, we have to find out the midpoint of AB. Midpoint of AB is the point at which these two lines are intersecting. So we can find out midpoint and the gradient of AB to find out the equation of the perpendicular bisector. Now we will take out gradient of AB. Gradient of AB is equal to 11 minus 3 upon 7 minus 1, which is equal to 8 upon 6, which is equal to 4 upon 3. Gradient of this perpendicular line is minus 3 upon 4. Now we have to take out midpoint. Midpoint is equal to 1 plus 7 upon 2, comma, 3 plus 11 upon 2. One plus 7 is equal to 8, and 8 divided by 2 is 4. So we have here 4, comma, 3 plus 11 is 14. 14 divided by 2 is 7. 4, comma, 7. Now we can find out equation using these coordinates and gradient. We can use the form y minus y1 is equal to mx minus x1. So y minus 7 is equal to minus 3 upon 4 x minus 4. We can do cross multiplication. 4 will be multiplied by y minus 7. So it is 4y minus 28 is equal to minus 3 multiplied by x, which is minus 3x, minus 3 multiplied by minus 4, which is plus 12. So finally, we have 4y is equal to minus 3x plus 12 plus 28, which is 40. So this is the equation of the perpendicular bisector of the line segment joining A and B. Let's do some questions related to equation of straight lines. We have to find equation of the line parallel to the line x plus 2y is equal to 5, passing through the point 2 comma minus 5. We have to find the equation of the line which is parallel to this line. So if this line is parallel to the line of which we have to find the equation, it means that we can take the gradient from this equation, because if the lines are parallel, their gradients are same. So first of all, we will take out the gradient from this equation. We will make y the subject. Whenever we have to find out the gradient from the equation, we have to make y the subject. So 2y is equal to minus x plus 5. We will convert it to the form y is equal to mx plus c. So y is equal to minus x upon 2 plus 5. So y is equal to minus 1 upon 2x plus 5. So minus 1 upon 2 is the gradient of this line, and the line which is parallel to this has the same gradient. So m is equal to minus 1 upon 2. Now, the line of which we have to form the equation is passing through the point 2 comma minus 5. So we will use 2 comma minus 5 for finding the equation of the line. We can use here y minus y1 is equal to mx minus x1. So y minus 5 will become y plus 5 is equal to minus 1 upon 2 x minus 2. We'll multiply this 2 by y plus 5, so it will become 2y plus 10. We'll multiply minus 1 by x minus 2, so it will be minus x plus 2. So 2y is equal to minus x plus 2 minus 10 will become minus 8. So this is the equation of the line which is parallel to the line x plus 2y is equal to 5 and passing through the point 2 comma minus 5. Now we have to find the equation of the line perpendicular to the line 2x plus 3y is equal to 12 passing through the point 7 comma 3. If the lines are perpendicular to each other, their gradients are negative reciprocal to each other. So first of all, we will take out the gradient of this line so that we can take the negative reciprocal of this to find the equation of the line perpendicular to this. So 3y is equal to minus 2x plus 12. Y is equal to minus 2x upon 3 plus 12 upon 3. We can write it as y is equal to minus 2 upon 3x plus 4. So minus 2 upon 3 is the gradient of this line. So m1 is equal to minus 2 upon 3. As you have to form the equation of the line which is perpendicular to this, so m2 is equal to 3 upon 2. Negative reciprocal, if it is negative, it has to be positive. If it is 2 upon 3, it is to be 3 upon 2. And the point is 7, 3. We can use y minus y1 is equal to mx minus x1 to form the equation. Y minus y1 is y minus 3 is equal to m is 3 upon 2, x minus 7. We will do cross multiplication. 2y minus 6 is equal to 3x minus 21. 2y is equal to 3x minus 15. And 2y minus 3x is equal to minus 14. Another question. The perpendicular bisector of the line joining A, that is minus 1, 4, and B, 2, 2, intersects the x-axis at P and the y-axis at Q. Find the coordinates of P and Q. P and Q are the points where the perpendicular bisector of the line joining A and B intersecting the x-axis and y-axis. To find out the points P and Q, we have to find the equation of perpendicular bisector of the line joining A and B. For the equation of perpendicular bisector, we have to find out the gradient of AB, which is 2 minus 4 upon 2 plus 1, which is equal to minus 2 upon 3. Gradient of line perpendicular to AB is negative reciprocal of 2 upon 3, which is 3 upon 2. This is negative, so it is to be positive. This is 2 upon 3, so it is to be 3 upon 2. Now we have to take out midpoint. For midpoint, we will add x values and divide it by 2. We'll add y values and we will divide it by 2. So we have here 1 upon 2, comma, 3. Minus 2 plus 1 is 1, so it is 1 upon 2. 4 plus 2 is 6. 6 divided by 2 is 3. Now we have to form the equation of perpendicular bisector of the line joining A and B. Y minus 3 is equal to 3 upon 2 x minus 1. We will do cross multiplication. 2y minus 6 is equal to 3 is to be multiplied by x, 3x. 3 multiplied by minus 1 upon 2 is minus 3. So we have here 2y is equal to 3x minus 3 upon 2 plus 6. 2y minus 3x is equal to 9 upon 2. We can multiply this 2 on this side, so it will be 4y minus 6x is equal to 9. Now we can find out the coordinates of P and Q. For P, it's on x-axis, where y is 0. So if we will substitute y as 0 here, so 4 multiplied by 0 will be 0, and we will be left with minus 6x is equal to 9. So x is equal to 9 upon minus 6, which is minus 3 upon 2. So we have minus 1 whole 1 upon 2. So the coordinates of P are minus 1 whole 1 upon 2 comma 0. Now we will take out coordinates of Q. Q is on y-axis, where x is equal to 0. So when we will take x as 0, then we will be left with 4y is equal to 9. So y is equal to 9 upon 4, and y is equal to 2 whole 1 upon 4. So the coordinates of Q are 0 comma 2 whole 1 upon 4. Now we have to find the length of PQ. Coordinates of P are minus 3 upon 2 comma 0. We have done in the last part. And the coordinates of Q are 0 comma 9 upon 4. PQ is equal to under root x2 minus x1, 0 minus 3 upon 2 will become 0 plus 3 upon 2 whole square, plus 9 upon 4 minus 0 whole square. We have 3 upon 2 square is 9 upon 4, plus 9 upon 4 square is 81 upon 16. You can take out LCM of 4 and 16. So we need to multiply this by 4, this by 4. So this will be 36 plus 81 upon 16, which is equal to 117 upon 16. Square root of 16 is 4. So we can write 4 in the denominator. 116 can be written as 9 into 30. Square root of 9 is 3, so we can write it as 3 under root 70, which is the length of PQ. Find the area of triangle OPQ, where O is the origin. As we know, the coordinates of P are minus 3 upon 2 comma 0. It is on x-axis, and Q 0 comma 9 upon 4, which is on y-axis. And O is the origin. If we draw this on a grid, then we will be getting a triangle. If we have here -1, -2 here, then this is -3 upon 2. So this point is -3 upon 2 comma 0, which is P, and Q is 0 comma 9 upon 4, which is 2 whole 1 upon 4. So 2 whole 1 upon 4 would be somewhat here. So this is the point, which is Q. Triangle would be like this. We will consider the distance from this 0 comma 0, which is origin, as base, and the distance from origin to this point Q as height. So we can use the formula for area of triangle, which is half into base into height. So base here is 3 upon 2. We will not be considering negative sign because we have to consider the distance from here till here. We have to use absolute value, which is 3 upon 2 multiplied by height, which is from here till here, 9 upon 4. So we have here 3 nines are 27 and 2 into 2, 4, 4 fours are 16, 27 divided by 16, which is 1.6875. Let's do a past paper question. Solution to this question by accurate drawing will not be accepted. It means that we don't have to solve it by drawing on grid. We have to do calculations. The points are A 4, 3 and B 12, -7 respectively. Find the equation of the line L, the perpendicular bisector of the line AB. We have already done the questions related to perpendicular bisector of the given line. For perpendicular bisector, you have to remember 3 things. You have to take out the gradient of the line, which is given. Then you have to find the negative reciprocal of it. And then you have to find out midpoint. And with the help of negative reciprocal gradient and midpoint, you will form the equation. So first of all, we will find out gradient of AB, which is -7 -3 upon which is equal to -10 upon 8, which is finally equal to -5 upon 4. The gradient of perpendicular bisector is 4 upon 5. It's negative, so it is to be positive. It is 5 upon 4, so it is to be 4 upon 5. Now we have to take out midpoint of AB. Midpoint of AB is equal to 4 plus 12 divided by 2, 3 minus 7 divided by 2, which is equal to 8, minus 2. 4 plus 12 is 16. 16 divided by 2 is 8. 3 minus 7 is -4. And -4 divided by 2 is 2. Now we will form equation. We will use y minus y1 is equal to mx minus x1. So y minus y1 is y plus 2 is equal to m is 4 upon 5 x minus 8. We will do cross multiplication. 5 multiplied by y is 5y. 5 multiplied by 2 is 10. We'll multiply 4 by x and 4 by minus 8. So 4x minus 32. So we have here 5y minus 4x is equal to minus 42. Part B, the line parallel to AB which passes through the point 5, 12 intersects L at the point C. Find the coordinates of C. The line which is parallel to AB has the same gradient as of AB. AB has gradient m is equal to minus 5 upon 4. So the line which is parallel to AB has same gradient minus 5 upon 4. And this line which is passing through the point 5, 12 intersects L at the point C. The equation of line L we have already taken out in the previous part, which is 5y minus 4x is equal to minus 42. Now, by solving these two equations simultaneously, we will be able to find out the coordinates of C. So, first of all, we will find out the equation of the line parallel to AB, whose gradient is minus 5 upon 4, which is passing through the point 5, 12. We can use the form y minus y1 is equal to mx minus x1, as we know one of the coordinate and m, that is gradient. So y minus 12 is equal to minus 5 upon 4 x minus 5. We will do cross multiplication. 4y minus 48 is equal to minus 5x plus 25. 4y plus 5x is equal to 25 plus 48, which is 73. We have another equation which we have of line L is 5y minus 4x is equal to minus 42. We can make x the subject by taking this on this side and 42 here. So 5y plus 42 is equal to 4x and x is equal to 5y plus 42 upon 4. Now we can substitute this value of x in equation 1, which is this one. 4y plus 5 into 5y plus 42 upon 4 is equal to 73. 4y plus 25y plus 210 upon 4 is equal to 73. We will multiply whole equation by 4. So this is 16y plus 25y plus 210 is equal to 292. When you multiply this by 4, so 4 and 4 would be cancelled out. Now 16y plus 25y is 41y, which is equal to 292 minus 210, which is 82. So y is equal to 82 divided by 41. Y is equal to 2. Now we can take out x by substituting y 5 into 2 plus 42 upon 4, which is equal to 52 upon 4. Which is equal to 30. So we have coordinates of C 13, 2. Just a quick recap. We can use slope-intercept form to find the equation when slope and y-intercept are known. When slope and one point are given, then we can use point-slope form. And when 2 points are given, then we can use point-point form to find the equation of the line. For perpendicular bisector, you have to take out midpoint and you have to take the negative reciprocal of the line which is already given in the equation. Hope this helped clarify straight line equations. Practice a few on your own and check your answers. And remember, understanding the why makes math much easier. Don't forget to like, share, and subscribe for more problem solving guides. Thank you very much.